The project and the importance of APIs. So the aim of the project is to expose you to a reasonably large collaborative programming project. And what you're going to do is experience creating a multi-tier architecture of software. I'll explain what that means in just a minute. What you're actually going to do then is create a simple genome browser to look at genes in a given human chromosome. This is what I mean by a multi-tier architecture. The important parts really for the purpose of what you're going to create are from the database through to a web front end. But obviously you're also going to need code to populate that database with the genome data. You then have, sitting on top of the database, a data access tier or database tier. And what that does is wraps up all the SQL that's necessary to query the database, so that the layers beyond that don't need to know anything about the database structure. So the person implementing the database and the data access tier could replace the database with something completely different and nobody else would care. The business logic tier contains functions which may simply pass directly to the data access tier, but also the things in the business logic tier may be doing some calculations, bringing together data from different places, and so on. The web front end obviously will have HTML pages and CGI scripts, and those CGI scripts take the data from the business logic layer and convert those results into HTML. So when I'm talking about tiers and layers, all that I mean is Python modules. Given that these two layers, the data access tier and the business logic tier, are simply Python modules, that means that the CGI script imports the business logic tier imports the data access tier, and that's all there is to it. So there are requirements and help on how to do this and how to write good quality code on the website, and we will go through that in detail in the live session. There's also a set of skeleton code that I've created on GitHub, and you can download that in order to give you a starting point. If you choose not to download that, well, simply I think that's not a good approach. You've been given information that shows you exactly how we'd like this to be done, so make use of it. Let's move on to APIs then, because this is something that every year students seem to find very complicated, difficult and confusing, and really it is incredibly simple. So an API is an application programming interface. So don't get scared by the terminology. It's nothing difficult or complicated at all, but it is absolutely critical to what you're doing when you're working as a team. So have you used things like a PEP 249 compliant module such as MyPySQL, the CGI module, things like Pandas, BioPython and so on? If you've used any of those, which you have, then you've used an API. So an API is simply a formal description of a set of functions. The name of the function, the parameters, what goes in, and the returns, what comes out. So let's take a simple little example. Suppose we have a CSV file called proteins.csv. Now, CSV file, each field should just be separated by a comma, but I've put in some spaces as well just to make it look a bit clearer. So in this little CSV file we have data from UniProt KB, we have an accession code, we have an identifier, we have a sequence length, and we have a molecular weight. So suppose we want a function that allows us to read columns from this file into a dictionary. Now, what we would like is to be able to specify the name of the file, a column number to use as a key in the dictionary, and a column number to use as the value in the dictionary. So using this function, if we've created a function called createDictionary, we'd pass it the file name, and if we passed it column 0 as the key and column 1 as the value, that would give us a mapping from the accession code to the identifier. Similarly, if we called the function but gave it column 1 as the key and column 0 as the value, then that would give us a mapping the other way round, from an identifier to an accession code. We could also imagine we might pass column 0, the accession, as the key, and column 2, the length, as the value. And that would obviously give us a mapping from the accession code to the length. And similarly, if we gave it column 0 and column 3, we'd get a mapping from the accession code to the molecular weight. So that's just an example of a simple function and the sorts of parameters it takes. And in all cases, it will return a dictionary using one of the columns as a key and one of the columns as a value. So let's define an API for that. It's very, very simple. All we need to do is say what the function does, say what the inputs are, the file name, which is the CSV file to read, and that's going to be a string, the key column, which is a number, counting from 0, of the column to use as the key of a dictionary, and that's an integer, and the value column, the number from 0 of the column to use as the value of the dictionary. Again, that's an integer. And then what does it return? Well, it returns a dictionary keyed by the column specified by key column with values from the column specified by value column. And that's of type dictionary. That is your API. It's nothing more than that. It's just a description of the inputs and the returns and what the function does. Now, given that we've got that definition, we can use a docstring in our actual code to contain that information. So here I've just defined our function, and I've created a docstring using 3 sets of double inverted commas, and I've put exactly the content that I had before. In other words, what my API was. Now, the next stage would be to create some dummy code. So at this point, obviously this is a relatively simple function, but at this point, if you were doing something that was a bit more complicated, you wouldn't actually write the code itself. You would write a dummy version of the code. So we've got our definition of the function. We've got our API definition saying what's going in, what's coming out. So then we include a few comments to say what this function is actually going to do. It's going to open and read the contents as a CSV file. And then we're creating a dictionary. And here I've just created a bit of dummy data in the dictionary. And finally, I would normally close the file if I'd opened it, and I would return the dictionary. Now, this dummy code is absolutely invaluable, because if people implementing the different layers of the system have implemented dummy code like this, it means that the person whose code is calling this function can go ahead and call it and get some information back in the correct format. So here's the real code. So once I've created my dummy code for all of my functions, I can start to implement the real code. And this is the real code here. So all I've done is to open the file. I've used the CSV module, which I've imported up here, to read those data. I've then created a dictionary. I've gone through each row in the CSV file, and I have created my dictionary, or populated my dictionary with the relevant data. I've then closed the file and returned the dictionary. Obviously, this code is rather simplistic. It ought to do some other things, like, for example, checking that the file was opened properly, checking that the CSV reader succeeded in parsing this as a CSV file. It should also check that the key column and value column are values that are allowed. In other words, we're not specifying column numbers that don't exist in the CSV file. But this just gives you an outline of the basic idea of the code. So, as I said, you must define your APIs. In particular, the API for the data access layer and the API for the business logic layer. Now, remember, those are just Python modules. So all you're doing when you're defining your APIs is writing a definition of what each module contains. In other words, what functions it will contain, what goes in, what comes out. That's all there is to it. When you've done that, you would implement the dummy code specifically for the business logic layer and data access layer. And that means that as soon as you've done that, the CGI script can call the business logic layer functions. And similarly, the business logic layer can call the data access functions, even though they are not doing anything real, but they are returning data in the correct format. Now, the CGI script obviously will contain Python code itself. It will obtain data from HTML web forms. It will then use the business logic layer to obtain the required information based on the inputs from the web form. It will format the information as HTML and return it to the web browser. The CGI script will not do any calculations itself. Those all happen in the business logic layer. It will not contain any SQL. It will not access the database directly. And it will not import or use the data access layer. Everything is done through the business logic layer. Similarly, the business logic layer Python module simply takes data that's been provided to it by the CGI script. It uses the data access layer together with any calculations it needs to perform to obtain the required information, and returns those data to the CGI script in a way that then the CGI script will turn into HTML. So the business logic layer will not generate HTML, it will not contain any SQL, and it will not access the database. However, it will access the data access layer. The data access layer, again, is simply a Python module. It takes requests from the business logic layer, it creates the SQL queries to access the database, and it returns data to the business logic layer. The data access layer will not create any HTML, and it will not perform any calculations on the data. Those things are the job of the business logic layer. So the key point here really is that the other layers will not care about the format of the database. They don't care whether it's all in one big table or it's in 100 different tables, or indeed whether the data might be stored in XML or some sort of NoSQL database, or indeed even in flat files. It's up to the data access layer to deal with all that and simply take requests for data and return data in the required format. What goes on beyond that, nobody else cares about. So in summary, you must create your API first, and then create your dummy code. The big advantage of doing that then is once that has been done, the different people in the group can work independently. Once the API has been defined for the business logic layer and dummy code has been created for the business logic layer, then that means that the person doing the CGI development can call those functions. Okay, they might not get the expected results back, but they will get results in the correct format. Similarly, the person writing the business logic layer can call functions from the data access layer once the dummy functions have been implemented. And again, just in the same way, they might not get back the data that they're actually asking for, but they will get back dummy data in the correct format. Now, inevitably, you may find that changes to the API may be required. You may have forgotten some feature that is needed. So it's not impossible for you to change those API definitions, but obviously you want to think about the API and plan it as well as possible right at the beginning, so that you can try to avoid changes unless they're absolutely necessary. If you do need to make changes, then you need to talk to the people affected. So if you are the front layer developer writing the CGI script, then you need to talk to the person developing the business logic layer and get that person to implement the changes for you. Similarly, if the business logic layer needs some other functionality from the data access layer, then the business logic layer person needs to talk to the data access layer person. Once again, every year people seem to find this confusing and complicated. It really isn't. The other thing is that every year people seem to underestimate the importance of doing this right at the beginning. It might feel like you're not actually achieving anything because you're not actually writing any code. But again, every year people realise at the end of the project how valuable it was if they'd done it properly, and how much they regret not doing it properly if they hadn't done it properly. So when it comes to the live session, we'll go through the requirements for the project itself in more detail.